Well, back science education consultants, online teachers of chemistry, biology, physics, and mathematics. We are here to serve you under all circumstances, wherever you are and whatever you are doing. Learning must continue. Back Science Education Consultants, our YouTube channel, you can follow us. Follow our online lessons in all subjects for both O and A level. The last time we met in mathematics, I was discussing for you a body being projected with initial velocity and set free to move in air. I said if that body moves freely in air under the action of acceleration due to gravity, neglecting all other forces, that is referred to as projectile motion. We were able to derive different expressions, and they included time of flight, horizontal range, maximum height, and others, as we are going to see. Today, we shall see how to apply these equations derived in the previous lesson to compute different calculations involving projectile motion. The first expression is for velocity at any time, and it has vertical and horizontal components. The time to reach the maximum height, which is given by that, and the time of flight, which is twice the time to reach the maximum height, the horizontal range R, and then the maximum height. Given these expressions and the question, we can be able to compute all these using the given variables. For example, given this problem, and we are going to tackle it using the formulas derived in the previous lesson. We have been told that this particle was projected with an initial velocity of 30 meters per second and at an angle of elevation of 30 degrees. It implies that if you draw a tangent to the velocity of 30 meters per second, then you put an angle of 30 degrees, the particle that is projected will describe a projectile motion and finally come back to the same horizontal plane. If this is horizontal axis X and then vertical axis Y, then we shall see that if we are required to compute the maximum height, we have been told, or we derived in the previous lesson, that the maximum height H, which is at this point, is got from H equal to U squared sine squared theta over G, over 2G. Then, given the initial velocity U, which is 30 meters per second, the angle theta of projection, and then acceleration due to gravity, which is a constant. For mathematics, we shall be using 9.8 meters per second squared, and it is acceleration due to gravity. So we can simply substitute and say this is H equal to U squared, that is 30 squared, sine squared of 30 divided by 2 times 9.8, and this gives us 1.5 meters as the maximum height. It simply implies that after projecting this body at 30 meters per second at an angle of elevation 30, the maximum possible height this body can move is 1.5 meters, and at that point, it simply turns back to the ground. So, Roman number 2 is asking us to compute the time of flight. The time of flight is the time taken for this particle to move from the initial point of projection to the same horizontal plane through the point of projection. And we say the time of flight t is got from the expression 2u sine theta divided by g. And so by substitution, we have 2 times u, which is 30, then times sine of 30 divided by 9.8. The time of flight is therefore equal to 0.06 seconds. It simply implies that after projecting this body, it will take 3.06 seconds to come back to the same horizontal plane of projection. Roman number 3 is asking us to compute. The horizontal range, and we said the horizontal range is abbreviated by capital R, and it is the horizontal distance traveled before or after the particles returned back to the same horizontal plane. And we said it is got from the expression u squared sine of 2 theta divided by g. By substitution, we have 30 squared sine of 2 times theta, which is 60 degrees. That is 2 times 30 divided by 9.8. And that will give us 79.53 meters. It simply means that after projecting this body with 30 meters per second at 30 degrees above the horizontal, it will move a horizontal distance of 79.53 meters to come back to the same horizontal plane. And that is all. So, after that, I'm going to give you an activity concerning the calculations on projectile motion, and we shall call it a topic. So, you can go through the question, look for the given variable, like given quantities, and look for what is not given. What is required, and what is given, and what is required. If you are given initial speed, you are given the horizontal range, and you are asked to look for the angle. You know from the expression for horizontal range, and then look for the value of theta. You get two possible values of angles. And maybe this has made me remember some aspect I did talk about, and we can simply go through it in a short period of time. The equation of trajectory. Has made me remember one aspect, equation of trajectory. This is, when they talk about trajectory, it simply means the path taken by a projected particle. If you have x-y axis, and then you project the body at an angle theta with velocity u, and then the path that this body takes is what we call the trajectory. The equation of trajectory therefore connects the vertical displacement y, connects the horizontal displacement x, and then the angle theta and the speed of projection u. So we shall see an equation connecting y, x, theta, and u. And how do we get it? We simply connect the vertical expression for the distance traveled, and then the horizontal distance traveled, and we eliminate the expression, we eliminate time. So from s equaling to ut plus a half at squared, we can look for the vertical distance traveled, vertical displacement, and we can also look for horizontal displacement at any time. And how do we get it? If it is vertical distance, then we call it y. And then we consider a vertical component of velocity times time. And if that is true, we add there a half at squared. But for the vertical motion, a changes into negative g. Reason we said the motion is opposing the acceleration due to gravity, and so we have negative g. If that is true, we said that the vertical component is given by u sine theta. If you multiply it by t, you get ut sine theta minus a half gt squared, and you call that one equation 1. Then in horizontal displacement at any time, we'll replace s by the horizontal distance traveled x, and then we'll replace u by the horizontal component of velocity and multiply any time t, and we add a half times acceleration due to gravity horizontally, it becomes 0, and then we multiply t at any time. This simply gives you the horizontal component after resolving becomes u cos theta, multiplying t gives u t cos of theta, and that one is simply equation 2. If you eliminate t in both equation 1 and 2 by making t the subject here and you substitute it here, what we get is what we call equation of trajectory. Let's see. Substituting in equation 1, theta, then times sine of theta minus g over 2 into t squared, which is x over u cos theta squared. And this gives you y equal to u goes with u, and sine over cos becomes tan, so we have x tan theta minus g x squared over 2u squared cos squared theta. And we know that 1 over cos theta is sec theta, theta is sec squared theta. So we have y equals x tan theta minus gx squared sec squared theta over 2. And this simply can be written as y equal to x tan theta minus gx squared over 2 into 1 plus tan squared theta. By trigonometry, sec squared theta equals 1 plus tan squared theta. Adding, collecting like terms together and forming a quadratic equation in terms of tan squared gives you y. In fact, there is a missing u here, 2u squared tan theta minus gx squared. You multiply by, let's multiply by 2u squared throughout here, and we shall simply get 2u squared here, 2u squared here, 2u squared y equal to 2u squared x tan theta, then minus gx squared times 1, and then gx squared times tan theta. Tan squared theta. This can be rewritten as gx squared tan squared theta, and then we bring gx squared equal to 0, which is a quadratic. Which is a quadratic expression in terms of, what does it tell you? It simply means that for every horizontal distance traveled and vertical distance traveled, for a given initial velocity, there are 2 possible angles of projection that give you the same horizontal distance. And we presented this on the diagram as if this is x, means that for a constant initial velocity u, we have 2 different angles of projection that can hit the same vertical distance and the same horizontal plane. This is practical. With the same velocity and at different angles of projection, these particles can travel the same vertical distance travel. And this is proved by the equation of trajectory. So this equation gives values of tan theta and therefore 2 possible angles of projection. I thank you. So subscribe to our YouTube channel, BAC Science Education Consultants, for more examples, and then you can reach us by commenting or putting there your question, and then we come tackle it. We shall be able to give you, under all circumstances, a like, share with other friends, and be able to learn throughout the pandemic.